Hi everybody, this is Walter Stone. This is Unit 8, Lesson 5. And in this lesson we are going to solve equations that involve radicals. And to solve equations of this type, we can raise each side of the equation to the same power. So if we have, there's a property that if a is equal to b, then if I raise both sides to the nth power, we'll get equal numbers. So what we can do is we can square both sides or cube both sides, that sort of thing. So in our example equations, we'll be using this type of property. So if we have the square root of x minus 3 equal to 4, and we want to solve for x, one thing to think about along the way is that x has to be a non-negative number. So it can be 0 or any positive number. So if we get a value that's negative here, that's going to be a problem. So that's one thing to think about as we go through this process. Also, we want to solve equations like we regularly solve them. We want to get to a place where the square root of x is alone, and then we can square both sides. So if we add 3 to both sides, we get the square root of x equal to 7. And then if we square both sides, we get x equal to 49. And if I put that back in the original equation, the square root of 49 is 7, and 7 minus 3 is 4. So that checks. So work with the equation on your lesson guide, square root of x minus 7 equals 3. Pause the video and then come back and check your work. So here we can add 7 to both sides, and we get the square root of x equal to 10. And then we can square both sides, and squaring the square root of x gives us x. 10 squared is 100. And if we check that, the square root of 100 is 10, and 10 minus 7 is 3. So here's a situation where we have the square root of x equals negative 3. And if we square both sides, we get x equals 9. But the square root of 9 is not negative 3. So another thing to think about is we can only take square roots of non-negative numbers. And if we are taking the positive square root, that number has to be positive. So another thing right away you can say is, since the square root of x is a negative number, right off the bat you can say this equation must have no solution, because the square root of a number must be a positive number unless we have a minus sign out front, and in this case we don't. So a question here is, does the square root of square root of x equals negative 2 have a solution? No, the same reason is that we're taking the square root of a non-negative number is always positive, so we can't have a negative square root there. Okay, so that's something to be on the lookout for. So here we have the x minus 5 equals the square root of x plus 7. We can square both sides, and if we square x minus 5, we get x squared minus 10x plus 25 equal to x plus 7. And we can subtract x from both sides and subtract 7 from both sides. So we get x squared minus 11x plus 18 equals 0. And we can factor. So we have x minus 9 times x minus 2 equals 0. And so that means that 2 and 9 are possible solutions. If we check 2 minus 5 is negative 3. So 2 really doesn't work. But 9 minus 5 is 4, and 9 plus 7 is 16, and the square root of 16 is 4. So 4 equals 4. So 2 does not check, and the solution is 9. So when we have situations like this, you just want to make sure that you are checking solutions and making sure that both make sense. So try this equation, pause the video, try this equation, and then come back and check your work. So we're using that same procedure. We're squaring both sides. If I square x minus 1, I get x squared minus 2x plus 1 on the left-hand side and x plus 5 on the right-hand side. And if I subtract x from both sides and subtract 5 from both sides, I get x squared minus 3x minus 4 equal to 0. And that factors into x minus 4 times x plus 1. So 4 is a possible solution and negative 1 is a possible solution. So if we put negative 1 back in the original equation, we get negative 2 on the left. And so we have the square root equal to negative 2, and that's not possible. So negative 1 does not check. 4 goes in for x. We get 3 on the left and the square root of 9 on the right, which is also 3. So 4 checks. So 4 is the only solution to this equation. So we really need to check our work and make sure we select the of our potential solutions. We check them and make sure that one or both work. Sometimes we might solve an equation where we have a radical on both sides. So the idea is to isolate a radical on one side, which this equation has that. The 2x minus 5 is on one side. And what we can do is we can square both sides. And when we square the right-hand side, we have to make sure that we use that the square of a binomial. So we can square the first term, take 2 times the product of the terms, and then square the last term. And then we want to simplify on the right and then isolate the radical on the right. So when we add 2 to both sides and subtract x from both sides, we have x minus 3 on the left equal to 2 times the square root of x minus 3. And then we can square both sides, and we get x squared minus 6x plus 9 on the left-hand side. 2 squared is 4, and the square root of x minus 3 is x minus 3. And we can distribute the 4 to the right-hand side. Then we can subtract 4x and add 12 to both sides, and it factors into x minus 7 times x minus 3. And so 3 and 7 are possible solutions. So if we check 3, 6 minus 5 is 1, so we get 1 on the right-hand side. 3 minus 3 is 0, and 1 plus 0 is 1. So we get 1 equal to 1. So 3 checks. We also want to check 7. 14 minus 5 is 9, so we have square root of 9 is 3. And then 7 minus 3 is 4, so square root of 4 is 2. 1 plus 2 is 3. So we get 3 equal to 3 when we check that solution. So it turns out that 3 and 7 are both solutions. So try this equation, try solving this using the same strategies, and you want to pause the video, come back when you're ready to check your solution. And here you can see that I made some mistakes along the way, but I corrected myself. So root 3x plus 1, that was isolated on one side. So we can square both sides. So we have 3x plus 1 on the left equals 1 plus 2 times the square root of x plus 4 plus the square root of x plus 4 squared, which is x plus 4. I subtracted 4 from both sides, and then I subtracted x from both sides, and I subtracted 1 from both sides. So we should have 2x minus 4 on the left equal to 2 times the square root of x plus 4 on the right, and we can square both sides. So when I square the left-hand side, I'll have 4x squared minus 2 times 2x times 4, which is negative 8x. So we get negative 16x plus 16. 2 squared is 4 times the square root of x plus 4 squared is x plus 4. So we can distribute the 4 on the right-hand side. The 16s will subtract out. When we subtract 4x from both sides, we get 4x squared minus 20x equal to 0. And that's 4x times x minus 5 equal to 0. So potential solutions are 0 and 5. If we put 0 in, we get 1 on the left and we get 3 on the right. So 0 does not check. If we put 5 in, we get square root of 16, which is 4 on the left, and 1 plus the square root of 9 is 3, and we get 4 on the right. So 5 does check. Okay, so please do the written exercises in this learning guide and do the homework online, and we will see you in class. Take care.